Hello, everyone. In this episode, I'll talk about generative and discriminative models in machine learning. And the motivation is that recently there's been in the news ChatGPT, which is generative pre-trained transformer models. And by now we have the fourth generation, GPT-4. GPT, it means generative pre-trained transformer, which is an autoregressive language model. And it's similar to transformer. And what is a transformer? I think it's similar to what we have sort of seen like encoders, like variation and all this. It sort of has an encoder part. It gives a latent space, which we call embedding. And then it has a decoder part, which generates the text again. Isn't it? There were precursor models like BERT, which basically had the encoder and decoder. But the GPT, basically, it uses the decoder part of the transformer. It's just, it's a much larger model than the transformer. So essentially, it is a decoder. And that's why it's called generative transformer, because it uses the decoder part. So today, I want to talk a little bit more about what does it mean to be generative. Some of the issues that can it be creative, like we wonder whether ChatGPT can be creative, or is it just interpolating some of the in-between points? So, well, I'll explain the two big branches of machine learning, discriminative and generative part. So what is a discriminative model? It's also called conditional model. And if there are here data points like this, okay, and in some questions or problems, we want to basically know what sets the boundary here, isn't it? Like what are the blue dots and red dots here? And we want to have a cutoff line which separates the blue and red dots, isn't it? So this is basically a discriminative model, if you will. It is many things that we do regression analysis, like logit regression in this case, isn't it? You can draw a line where if it's below or above the line and have a logit regression. These are the typical examples, but they're also machine learning, support vector machines, decision tree, random forest, and these sort of models. So in your view, I guess the most common thing, it is a regression. So what else do we have in machine learning? So if we have the same dots, the blue and red dots here, there are cases where we want to focus on the distribution of the individual classes in the data sets, meaning that tends to model the underlying distribution of the data points. Like, I guess, if for economists, the common thing is Bayesian learning. Isn't it? What is the exposed posterior distribution that generates this or this? Isn't it? So that's basically what a generative models does. And there are some fundamental differences in that. Well, the discriminative model tends to be interpolating, isn't it? Any predictions are basically this line and it's interpolative. Whereas once you get the distribution, you don't actually have to get this dot or this dot. You can just randomly pick anything from the distribution. So in that sense, it's generative. So have we seen in recent hour episodes some of the things? I will show two generative models that we have learned. The first thing is variational autoencoder. I remember we have a portional image going to encoder. We get a distribution, and we don't actually directly have the distribution going to decoder, but we randomly sample and get a point and go through a decoder to recreate the image. And this is, if you haven't noticed, is like Bayesian estimation, isn't it? You have a data set here. It goes through an encoder. So you gotta have the latent space, the posterior prior distribution, and then you go that latent space to decoder to the data set. And what in the latent space happens is that there's an actual distribution like this, but we are fitting it into a normal distribution. So that's what it does. And once we have that, if we just take the decoder, you can give any random number, not the one that is have been in the sample. So by giving any random number, it will generate something through the decoder, and that will be a new data set that is not in the original sample. In that sense, it is generative. It creates new data. We also seen similar model like that which is a gun. Remember, you have a generator network that tries to create the fake data. And there's another competing network, the discriminator network, that basically tries to distinguish the real and fake data. And the generator trying to fool the discriminator gets better and better and better. And at a stalemate, what it ends up being is that like a decoder, if you just take the generator and it started with the random seed to generate a fake data, but nowhere it's in the real data, it is a new thing. So in that sense, it is generative, what we call. Okay, so that was a quick mention about the discriminative and generative model in machine learning. And discriminative tends to be regression kind of framework. So which is a prediction is like an interpolation. And the generative machine learnings are like Bayesian learning, tries to learn an underlying distribution. And once you have that distribution, you can just pick any random number from the distribution and create a new data. So in that sense, it tends to be more creative. It generates data. So this was a quick overview of the discriminative and generative network. Thank you for watching this episode.